This is the differential equation in slope fields, worksheet number 2. Let's look at number 1. Given the differential equation dy over dx equals x over y, and given ordered pair, -3, -2, find the particular solution. So we need to go through the steps to solve the differential equation. We separate the variables. Y is on the left, x is on the right. Take the integral of both sides. Power rule for both, y squared over 2 on the left, x squared over 2 plus c on the right. We can either multiply everything through by 2, or we can just go ahead and solve for c. So replace the y value with -2, replace the x value with -3, and we're simply using the ordered pair that's provided for us. So we get 4 over 2, which is 2, and 9 over 2. Subtract 9 over 2 from both sides. We get -5/2. So y squared over 2 is equal to x squared over 2 minus 5/2. At this point, we can begin to solve for y. So multiply everything through by 2. We get y squared equals x squared minus 5. Still, we need to solve for solve for y. So we take the square root of both sides, and we have two equations to choose from, either a positive square root of x squared minus 5 or negative square root of x squared minus 5. And we see that because we need the y value to be negative, then we're going to have to have a negative square root in order for this ordered pair to be true. So if I plug -3 in for x, I'll get 9. 9 minus 5 is 4. Square root of 4 is 2. And the negative out here guarantees we get a negative y value, which is what the ordered pair calls for. Okay. Now, if you graph this, negative square root of x squared minus 5, here's what the graph will look like. Okay. And we know that the graph is going to go through that point. We're going to follow the basic pattern of this slope field. And however, we also have to keep in mind that there is a restriction at y equals 0. All right. We know that based off our differential equation, y equals 0 would be undefined. So we put an open circle here. Okay. And remember, if we want to find the domain, then it's the largest open interval containing the initial value. So we basically just have to find the domain for this region. So this region is from -infinity to whatever this x value is. This is the furthest right that the graph will go. So if we want to find the x value, then we simply look at the equation, replace y with 0, because that's where the restriction is. So if I replace y with 0 and I solve for x, I can square both sides. I get x squared minus 5 equals 0, x squared equals 5, so therefore x is equal to plus or minus root 5. And this ordered pair, this x value is obviously negative, so negative square root of 5. So that's why our domain is x is from -infinity to negative square root of 5. Okay, part C, find the equation of the tangent line when x equals negative square root of 6. So if I want to find the equation of the tangent line, I need two pieces of information. I need the ordered pair, and then I need the slope. So to find the ordered pair, I can simply plug -√6 into our equation. So if I plug -√6 into the equation, I will get negative square root of 6 squared, which would just be 6. So 6 minus 5 is 1, so -1. So my ordered pair is negative square root of 6, -1. And now, if we want to find the slope, then we can go back to our differential equation, right? This is our differential equation. This is our derivative rule. And the derivative rule says it's x over y. So remember, your differential equation can also is your derivative function, which is used to find the slope at any given point. So if I plug -√6 in for x and -1 in for y, I can simplify and solve, and I get my slope is equal to √6. So from there, plug into your point slope form. So y plus 1 is equal to √6 parentheses x plus root 6. So here is our tangent line equation. And then we can go to part D. Use this to approximate negative 2.5, the y value of negative 2.5. So we simply replace the x value with negative 2.5 and plug all this in the calculator, and you'll get negative 1.124. Right, number 2, we have the differential equation, dy over dx equals 1 over x. So we follow the same steps here. Find the particular solution. So we separate the variables. Y is on the left, x is on the right. The left side is simply just going to be y. And the right side, this is in the form of 1 over u, so natural log of the absolute value of x plus c. Next step, we can solve for c. And we have the ordered pair 1, 1. So plug 1, 1 in for the x and the y value to find the c value so we can identify the particular solution. So y gets replaced with 1. X gets replaced with 1. Natural log of 1 is 0. So we get c is simply equal to 1. So our particular solution is y is equal to natural log of the absolute value of x plus 1. So if we were to graph this, and we know that the graph has to go through that point, and also in our calculator, we're going to see a graph. If we just follow the flow of this graph, this is what our graph looks like. Okay? And we know that there is an asymptote here at x equals 0, based off of our differential equation. So just based off of this graph, we can tell what the domain is going to be. The domain will be from parentheses 0 to where x has to be greater than 0. So our domain is from 0 to infinity. Okay. Part C, find the equation of the tangent line. So if I want to find the equation of the tangent line, I need the y value first because I need the ordered pair. So I plug e in for x so we can find the y value at that point. So natural log of e is 1. 1 plus 1 is 2. So my y value is 2, so my ordered pair is e2. Now if I want to find my slope, I go to my derivative function, right? So derivative function is just 1 over x. So 1 over x, my x value is e, so 1 over e. So that's my slope. I have my point, I have my slope. Plug into point slope. Y minus 2 is equal to 1 over e times x minus e. Okay. Part D, use the tangent line to approximate 2.8. When y of 2.8. So basically, all we do is plug 2.8 in for x, and then we just solve for y. In our calculator, we're going to get the y value at 2.8 will be approximated to be 2.030.